Hey guys, FuzzyNop here. Welcome to what I think is video 3. In this video, I'm still working through IDA and we're still at a very basic level. And for the format of this one, I'm feeling kind of lazy and I'm not going to do a lot of editing. I do kind of yammer on a lot. And I'm just basically walking through some basic stuff and just explaining it as I go and trying to explain how to use IDA and the functions and kind of some of the information that I'm drawing from it. So if you don't like this format, give me some feedback, let me know. Say like, we need things more specific, I don't want to watch a 15-minute video or something like that. If you do like this format where I'm basically just talking away, let me know that, and that'll help me get videos out a lot quicker. But I'm going to give this a try, and I hope to get some feedback from you. Here we go. Hope you enjoy. Looking at IDA now, this is Lab 6-04. If you were following along from the last video, maybe hit escape a few times to get back up to where IDA thinks the start of everything is. And in this case, it thinks this thing is the start, and it's called it main. Like, we'll trust it, okay? If this is the first time we've opened it up, we haven't looked at anything yet. Maybe we ran like strings on it or something. But IDA also has the ability to view strings, and you can pull that window up by, and I like to click on the main window so that it opens like in a large window. You can hit Shift and F12. So Shift and F12 gives us a list of strings, and these strings are referenced within IDA somewhere. So there's actually a reference to these strings, and it's not just crap data somewhere, typically, or we hope it's not crap data somewhere, right? And we see lots of interesting things, and in this case, we're pretending that we're reversing some piece of malware, okay? And this is going to still be valid if your reason for wanting to reverse engineer is different. So maybe you are interested in cracking software, like good for you. This is still going to be useful and this is still going to be valid. So just follow along and let's pretend we are reverse engineering malware, okay? So we see a couple things, all of them are interesting, and say we want to take a look at this string. It's a web address, and maybe it communicates with this web address, who knows? But if we double click it here, what we get is the point in the data section of where this string is stored, and we can see that it's referenced by this data xref here and where it is. We could double click to follow where the reference comes from, or we could hit escape to come back here, or we could click here and we could hit Control X to see where the cross references to this string are. And there could be more than one. Keep that in mind. Typically, there's not going to be. But so here we are in some function, and we're zoomed all up close and personal. So my first step, get a good overview of what's going on. Looks like a decision here, a decision here, a decision here. This could be a series of if then else statements. You know, like here we come, we take a look at something. If things don't work out right, come here. And then if we're still checking, come here, try this. If things don't work out, we quit here. I'm going to guess that these functions on the like false end of the jump or the negative end of the jump are going to be like not good, and that's just based on the positioning and the order that they are in. So like the most interesting stuff is probably going to be down in here, right? Just because a jump is red does not mean like bad. Just because like this red jump, like this could be like, you know, do all the really important stuff that we care about. But anyways, the only way to know is to actually look at it. So clicked on it, I hit 1. Luckily, whoever programmed this put in some debug strings for us. That's really nice of them. And it says error, failed to open URL. So like, hey, thanks for that. It could be misleading, but I'm going to trust it for now. We see this function call here. I'm going to drill into this. If you remember from the last video, this looks pretty familiar. I'm going to drill into this function. Hit W. This is our printf. We talked about this before. What I'm going to do is so that I don't get misled again and drill down into this crappy printf function that I know what it does. It just prints stuff out or somewhere, right? I'm going to name it. I'm going to hit N to bring up the rename address, and I'm going to say printf is what this is. And then this function that kind of encapsulates it, I'm going to call it printf wrapper. I'm We can see it's called in a bunch of places. I want to go back to where I was though, so I hit Control X to bring up the X references, cross references there, but I can't remember which one I picked before. Luckily, hitting Escape takes me back to where I was, and that's what I want, back to where I was. And we can see that internet close handle is how it kind of finishes up, and it comes down here and returns. Cool. Looking at this other jump right next to it, and if you want to see, I've highlighted this one. This is where we're at. It's this second branch. This seems to also be error, failed to read file. Cool. Here's our printf wrapper that we've named. You can see that IDA has seen like, hey, this is the same memory address, this is the same function, so we're going to call it the same place everywhere you name it. So as you name things, IDA is going to like populate that through everywhere it can so that you can understand like, oh, I've seen this before, this is what this is. So let's move on to over here. This doesn't have a whole lot of information, so maybe we don't know what it is. But just like we renamed the function call, we can rename these stack variables. And what this is EBP is typically a base pointer, and IDA has figured that this variable gets referenced somewhere, and it's at this offset of the stack. And you're probably interested in this. And instead of, like if I hit H here, I can see that the value that it's trying to reference is EBP minus 556, or 220C in hex. Like, cool. That doesn't tell me a whole lot. That's hitting H gives us those numbers. Hitting K is going to give us back the like variable representation. Now we can rename these variables, and I'm just going to say like maybe something, and you can put question marks in here too. I like to put question marks because a lot of times I feel dumb and I don't know what the hell I'm looking at. So question mark, like how unsure am I about it? If I really don't know what the heck this is, maybe like I have a couple question marks in here. Who knows? So here we go, another error message here. Cool, seems pretty interesting. Now, in this case, I want to know what this is or why it's used. Now, there's a couple things we can do. We can click on this and we can press X to see if there's any other places where this variable is used within this function. And it looks like there isn't. Now, another way to get that same information is clicking on it, and then we can look through, and what IDA will do is highlight any places that it's used. And since it's not used anywhere, we don't see it highlighted except for all the way back at the top here. And this is actually just information about the stack variables that IDA has identified for us. And we could rename it from here if we already knew what it was. Not worry about it. So let me tell you how I know what this is. Okay. In each of these functions here, we see XOR AL, XOR AL. Now, if you don't know what AL is, real quick, it's the lower part of EAX, the register. And the significance of EAX is typically that the return value of the function is going to be inside EAX. So what this is doing by XORing AL with itself, it is zeroing out that value. So like EAX or AL, it's going to be 0. Okay? And like we know that, or we assume that this is an error, so it's going to return 0. XOR AL, AL doesn't get touched anywhere else, it's going to return 0. In this case, it's going to return whatever this value is, because this is being moved directly into AL. I guess maybe it's 1 or something like that, or the error code, who knows. Maybe it gets set somewhere else, but we don't have that information right now. So we can guess that this is return value, and now that we have some more information, I'm going to say like return value good. All the other ones are errors. I'm going to assume that like this is the path that we're interested in. Now, I don't want to get too deep into analysis of this because I think this video is already starting to run probably a little bit long. So I'm going to cut this video short right here so it kind of stays under 10 minutes. The next video is basically going to just pick back up in the same spot. If you are super bored by this and not learning anything, you should probably skip the next video. I'm going to be posting some news shortly, and If you want to reach out to me on Twitter, I'm at FuzzyNop, or Gmail or something like that. Post a comment on the YouTube video, whatever you like. Peace.